Today I want to talk about parameter passing mechanisms in Java and C++. Specifically, Java passes primitives and object references by value, whereas C++ supports multiple parameter passing mechanisms. Now, the whole passing object references by value thing seems to confuse a lot of people, so I've prepared a little example program to demonstrate what I mean by that. So let's start in the main function. We have two string variables s and t bound to the strings world and hello, which looks like this. Here you can see it. And then we call another function, passing s and t as arguments. So what exactly does this mean? It means that the variable s will be copied into the variable a, and the variable t will be copied into the variable b, as you can see over here, right? So just the contents of the variables were copied into the corresponding parameters. And now there's no connection, no direct connection between A and S, and no direct connection between B and T. Which means the modifications to A and B via assignments will only affect the variables A and B, and they won't have any effect on the variables S and T, as you can see over here. So the system out print line inside the swap function will print A and B, so hello world. And then when we return to the main function, S and T remain unchanged. So the second system on print line will print S and T, so world and hello. Let's see if that's indeed what happens. There we go, exactly as predicted, right? So the fact that the parameters are copies of the arguments at this level means that Java passes object references by value. How would we fix this program? In Java, there is no way to fix it. So it is impossible to pass the variables themselves to a function so that the function could manipulate them. So in Java, this problem is unfixable. So every time you need to swap two variables, you will have to write these three lines. And that's a symptom of Java always being passed by value. Now, before we move on to C++, let's quickly look at C#. I simply translated the Java version to C#, and it will give you the exact same output as you can see here. So C# also passes string references by value, but C# gives the programmer a choice. When we want to pass by reference, we can simply add the ref keyword in front of the parameters and in front of the arguments, and then you will see a different output in the terminal. Here you can see it. Now S and T have indeed been changed. So with the addition of the ref keyword, A is no longer a copy of S. They're basically the same variable instead. And B is no longer a copy of T. They're basically the same variable instead, which means that when you assign to A, you really assign to S. And when you assign to B, you really assign to T. So C# gives you a choice. If you want to pass by value, you don't write the ref keyword. And if you want to pass by reference, you simply write the ref keyword in front of the parameters and in front of the arguments. Now let's look at the C++ version. Again, I translated the Java code to have the exact same effect. So again, A is a copy of S, B is a copy of T. So by default, parameters in C++ are passed by value. If we want to pass by reference, we simply add an ampersand at the end of the parameter types. We don't have to change the arguments at all. And now if we run the program, you will see the desired effect. And note that when you pass by reference, the arguments have to be variables, because if you look at the pattern, we initialize some variables, then we pass them by reference, and then we expect the variables to have been changed. If we pass something else that isn't a variable, for example, a concatenation of multiple strings, then C++ will reject the compilation of the program because it simply doesn't make sense, right? What would the assignments to A and B mean to the caller if the things he passes in aren't variables? There would be no way to inspect the changes, and that's why C++ prevents these kinds of problems at compile time. Now C++ gives us a third option for parameter passing, and I want to motivate it with a different example. Let's say we have a funny looking string, we print it to the terminal, reverse the string in place and print it to the terminal again. How would we write that reverse function? Well, of course, we have to pass the string in by a reference because we want to change it. And fortunately, in the standard library, there is already an algorithm that can reverse lots of things. And we simply say we want to reverse A from the beginning to the end. And that should already be it. Let's see. Yeah, here you can see before the call to reverse and after the call to reverse. Okay, cool. Now, for these kinds of string manipulations, these days, some people prefer more functional approaches. So don't modify the string in place. Instead, give me a modified copy. So let's call the function slightly differently to emphasize its functional nature. How would we write that guy? Well, it must return a string, right? Then we call it reversed. And since we don't want to modify the input, we pass it by value. Okay. And how would we now get a reversed copy? We could, for example, say we make a new string that goes from the reverse beginning to the reverse end of the input, and then simply return that. There you go. Here's the reversed copy. Here's the unchanged original. But if you think about it, we copy S into A, then we only read from A, and later A is destroyed. So we don't really need this copy. So why don't we pass it by reference to avoid the copy? That works. But the problem is reference parameters require the arguments to be variables. What happens if this is a more complicated expression? For example, if you simply add the empty string, this is no longer a variable, and so C++ will refuse to compile. So now comes the third option. We can say we want to prevent a copy, but we only want to read from the original. Then we can add a const at the front of the parameter type, and then everything will work again, and we don't get any superfluous copies. Okay, cool. There's another possible implementation for this function. Let's say we copy the function and rename it so we don't lose it. Let's say we didn't know that this cool constructor existed, okay? What could we do instead? We could simply copy the string and then reverse it with the function that we already wrote above. That would be this reverse function. And then we return the reversed string, and that has the exact same effect. And now we can think about, well, we just explained how we can prevent a copy. And the first thing that we do inside the function is make a copy ourselves. That's why do we make our life so complicated? We can simply get a copy by passing by value. Then we don't need to do it ourselves. And then, of course, we want to use A instead of B. There you go. Okay, so these are the choices that C++ gives you. You can pass by value if you need a copy or if copying is cheap, like ints or doubles. You can pass by reference if you want to modify the original, or you could pass by const reference if you don't want a copy and you only want to read from the original. To finish this video, I would like to emphasize that the term reference means completely different things in Java and C++. So the purpose of Java references is reference semantics, which I explained in the previous video, whereas the purpose of C++ references is pass by reference, which I explained in this video. Java references can be null. That's why you tend to see lots of null checks in Java programs. They can be rebound to refer to different objects at any time, and you can compare them to check if two references point to the same thing. Okay, none of these things is possible in C++. C++ references are never null. There's no such thing as not a variable that a reference is bound to. You can't rebind references. We saw in the swap example that the assignment operator directly modifies the referee and not the reference. And you also can't compare them. This will also compare the referees in the case of C++ references. If you want to disambiguate the terms so you don't get them confused, some people like to call Java references pointers because, well, we have null pointer exceptions, so why don't we call them pointers instead of references? And if you like the term reference as it is defined in Java, you can rename C++ references to aliases. That's what many C++ books tend to do. And that's it for today.